Hello, today is round 2 of line of best fit, and just give this a second and it'll quit shaking. All right, so just some things to review before we do some examples. To sketch a line, you have to have half of the points above and half the points below. So this is what we call the line of best fit. And so you have half the points above, half the points below, and you'll see that it does go through a few of them, which is okay. So this would be half of the points above the line and half the points below. That's what we're looking for when we do the line of best fit. Okay, the line must intersect at least 2 points to be able to find the slope. And the first thing we want to do is find the slope in order to find our line of best fit. So you're going to use 2 points and you're going to find the slope of the line. So let me quick review how to do that. If you'll remember, your slope is the change in y over the change in x. So if we had 2 points, like 6, 8, and -2, 4, if you'll remember, we stack the points and we find their change. So your x values are 6 and -2, and your y values are 8 and 4. A common mistake that a lot of you are making is you're putting the same point, the x and the y, on one side. Your points are horizontal. So 6, 8 needs to be next to each other just like it is here, and -2, 4 needs to be next to each other just like it is here. All right, and then to find the change, from 8 to 4, you're going down 4. And from 6 to -2, you're going down 8. So that's how we calculate the change. And then we're just going to do the change in y over the change in x. So the change in y here is -4, change in x is -8. And then you're going to put that in your calculator. So here's your calculator. You're going to say -4 divided by -8, and then you're going to hit math, enter, enter, and it will reduce the fraction for you. So that's 1/2. So our slope would be 1/2. So that's how we calculate the slope of the line of best fit. All right, and then in order to write the equation, you're going to use your slope and 1 point to write the equation. It doesn't matter which point you pick as long as it's on the line. So here, if these 2 points were on the line, I would just pick one of those. All right, so let's go ahead and review. The points that we're going to use for example 1 are 16, 300, and 22, and 510. So if you look at your graph, 16, 300 is right here, and 22, this is a little bit above, 510 is right there. So those are the 2 points that we're going to use to calculate our slope and write our equation. So we're going to stack the points just like I did above. And again, 16, 300 goes next to each other because that's your x and y. And then 22 and 510, and then you're going to look for the change. So when you go from 300 to 510, you're going up by 210. And when you go from 16 to 22, you're going up by 6. So then to calculate your slope, it's change in y over change in x. So you're going to say 210 over 6. Put that in your calculator. You can hit math, enter, enter. If it's a fraction, it will reduce it. This is not. It just comes out to be 35. So that is your slope. That is your m. To write your equation, you're going to start with point slope form, which remember is y minus y1 equals m times x minus x1. And so this is your x and y from 1 point. Remember we said we're going to need 1 point, and then your slope, which you found right here, is 35. So we're going to plug in the slope, 35, and we're going to plug in 1 point. I'm going to use the point 16 and 300. So 16 is the x, it goes with the x. 300 is the y, it goes with the y. And then in your steps, remember it says to distribute. So that's to distribute the slope. So we're going to multiply that. So this is 35 times x is 35x, and 35 times -16 is negative 560. This side we're going to leave as it is and bring it down. And then the last step, it says to isolate the variable y, get y by itself. So we're going to add 300 to get rid of that, and we have to add it to both sides. So y equals 35x minus 260. Now, that is it. You do not have to put it in standard form. We're just going to leave it in slope-intercept form. Now, some of you that are kind of with it, you might look at this and say there's no way that that graph crosses at negative 260. Negative 260 would be way down here. Well, this graph starts at 10, so you have a whole nother portion of this graph that you would have to pull out to see where this line crosses. So you wouldn't be able to just guess where this line crosses the y-axis at, because you're missing 0 through 9 on the graph. Okay, so if you stretch this out, this line will keep going, and it probably will cross somewhere near this negative 210. Again, I just use these 2 points. So if you use different points, you may get something close to this. It may not be exact. All right, let's look at example 2. We're going to do the same thing. I'm going to give you the 2 points that you need to use. We're going to use 270 and 540. Okay. On your worksheet today, you will be given the 2 points that you need to use to find your slope. So you won't have to look at the graph. You'll be able to use the 2 points that are given. All right, so to calculate the slope, we're going to stack the points just like we did. This is x, this is y. So this goes on this side, this goes across from it, and then 5 and 40. You're going to find the change. So to go from 70 to 40, you're going down 30. And from 2 to 5, you're going up 3. So your slope is the change in y over the change in x, which is negative 30 over 3, which equals negative 10. Again, put that in your calculator, negative 30 divided by 3, and it will give you negative 10. All right, then we're going to plug it into point slope form, which is y minus blank, which is y1, equals blank, which is your slope, times x minus blank, which is x1. So we're just going to fill in those blanks. We already know that the slope is negative 10. And then we're going to choose 1 point. So you can either do 270 or 540. I'm going to do 270. 2 is your x, it goes with the x. 70 is your y, it goes with the y. And then you're going to distribute the slope. That's your first step. It says it on your sheet. So negative 10 times x is negative 10x. Negative 10 times negative 2 is positive 20. Remember, you have to distribute that. You can't add 70 until you get rid of these parentheses. And then this comes down. And then you're just going to add 70 to both sides. So y equals negative 10x plus 90. And this is our equation. Now we can compare that to our graph over here, because it does start at 0 on both the x and the y, and you can see that your graph does cross at 90. So this graph does match our equation. All right, and then the last example is just reading the graph and being able to pull some information from it. And so we are told that this graph shows the line of best fit for data that was collected for the number of medium pizzas sold at local pizza shops and the amount of money earned in sales. So this is how many pizzas were sold. This is how much money that they earned. And it says, based on the line of best fit, how many pizzas were sold if $97.50 was earned. Now, some of you might go, where is that exactly on this graph? Well, this is it's skipping a box and then going up to 65. So this is halfway. So if you did 65 divided by 2, it's going to give you 32.5. So our graph is actually going up by $32.50 each time. So this right here is $32.50. Then we have 65. If we add another $32.50 to this, that's where we get that $97.50. So this right here represents $97.50. And if we go over to where we hit the line, that's right here, and we go down, we're halfway between 10 and 20, which is 15. So our answer here would be 15 pizzas. In this case, we were given the output, which is the money earned, which is on this side of the graph, the Y, and we were trying to figure out the number of pizzas sold. Sometimes they will give you the number of pizzas sold and ask you to find how much sales were earned. So in that case, we would look for the input here, which is number of pizzas sold, and we would go up to the line and see where it intersects. All right, good luck on your homework.